Top 20 AC interview questions and answers. Preparing for an air conditioning AC technician interview requires a solid understanding of HVAC systems, troubleshooting, and customer service skills. The following compilation of the top 20 AC interview questions and answers is designed to help candidates excel by covering key technical and PRA to call aspects. From the main components of an AC system and the refrigeration cycle to diagnosing issues like refrigerant leaks or compressor failures, these questions address critical knowledge areas. Additionally, topics like installation, maintenance, electrical components, and effective communication with customers are included to ensure a well-rounded preparation for aspiring AC professionals. 1. What are the main components of an air conditioning system? An air conditioning system comprises 4 primary components: the evaporator, compressor, condenser, and expansion valve. The evaporator absorbs heat from indoor air, cooling it. The compressor circulates refrigerant by increasing its pressure. The condenser releases absorbed heat outdoors, and the expansion valve regulates refrigerant flow, reducing its pressure. These components work together to cool and dehumidify indoor spa CS efficiently, ensuring comfort. 2. Explain the refrigeration cycle and its key stages. The refrigeration cycle cools air through 4 stages: evaporation, compression, condensation, and expansion. In the evaporator, refrigerant absorbs heat, turning from liquid to gas. The compressor increases the gas's pressure and temperature. In the condenser, the hot gas releases heat, condensing into a liquid. The expansion valve lowers the liquid's pressure, cooling it before it re-enters the evaporator. This cycle continuously removes heat from indoor spa CS. 3. What is the difference between a split AC and a window AC? A split AC has 2 units, an indoor evaporator and an outdoor condenser, offering quieter operation and flexibility in installation. A window AC is a single unit combining all components, installed in a window or wall, making it compa-CT but noisier. Split ACS are more aesthetically pleasing and efficient for larger spa CS, while window ACS are cost-effective and simpler to install for smaller areas. 4. How does a thermostat work in an AC system? A thermostat regulates an AC system by sensing indoor temperature and controlling the unit's operation. It compares the room's temperature to the user's set point. If the temperature exceeds the set point, the thermostat signals the AC to start cooling. Once the desired temperature is reached, it shuts off the system. Modern thermostats may include programmable settings or smart technology for enhanced energy efficiency and remote control. 5. What are the common refrigerants used in AC systems, and why is R410A replacing R22? Common refrigerants include R22, R410A, and R32. R410A is replacing R22 due to environmental concerns. R22, a hydrochlorofluorocarbon, HCFC, depletes the ozone layer and has a high global warming potential. R410A, a hydrofluorocarbon, HFC, is more environmentally friendly, with zero ozone depletion potential and better efficiency. Regulatory phase-outs of R22, e.g. EPA bans, and its rising costs have accelerated the shift to R410A in modern AC systems. 6. What would you do if an AC unit is not cooling properly? To address an AC not cooling properly, first check the thermostat settings for a Curie psi. Inspect and clean air filters, as clogged filters restrict airflow. Examine the evaporator and condenser coils for dirt, cleaning them if needed. Verify refrigerant levels, as low levels indicate a leak. Check for block vents or duct issues. If problems persist, test electrical components like the capacitor or compressor for faults, consulting a technician if necessary. 7. How do you diagnose and fix a refrigerant leak? Diagnose a refrigerant leak by inspecting for oily residue on AC components, using a leak detector, or applying soap solution to connections to spot bubbles. Check evaporator and condenser coils, tubing, and fittings. Once located, fix the leak by tightening connections, replacing damaged parts, or soldering small holes. After repair, evacuate the system, recharge with the correct refrigerant amount, and test for proper operation to ensure no further leaks. 8. What causes an AC compressor to fail, and how can it be prevented? AC compressor failure can result from electrical issues, for example, voltage spikes, low refrigerant levels causing overheating, dirty coils reducing efficiency, or lack of lubrication. Prevent failure by scheduling regular maintenance, including cleaning coils, checking refrigerant levels, and inspecting electrical components. Ensure proper installation to avoid strain. Use surge protectors, and replace air filters regularly to maintain airflow. Promptly address unusual noises or performance issues to extend compressor lifespan. 9. Why does an AC unit freeze up, and how do you resolve it? An AC unit freezes due to restricted airflow, e.g. dirty filters, blocked vents, low refrigerant levels, or malfunctioning blower fan. Resolve it by turning off the unit to thaw ice, replacing or cleaning air filters, and checking for duct obstructions. Inspect refrigerant levels and repair leaks if needed. Ensure the blower fan operates correctly. Schedule professional maintenance to address underlying issues and prevent future freezing. 10. How would you troubleshoot an AC that turns on but blows warm air? For an AC blowing warm air, verify thermostat settings and ensure it's in cooling mode. Check for dirty air filters or blocked vents restricting airflow. Inspect evaporator coils for dirt, cleaning if necessary. Confirm adequate refrigerant levels, as low levels suggest a leak. Test the compressor and capacitor for functionality. If issues persist, examine electrical connections or consult a technician to diagnose complex component failures. 11. What steps do you follow when installing a new split AC system? To install a split AC, select an appropriate location for indoor and outdoor units, ensuring proper airflow and accessibility. Mount the indoor unit on a sturdy wall. Connect refrigerant lines and install the outdoor unit on a level surface. Run electrical wiring and drainage lines. Vacuum the system to remove air, then charge with refrigerant. Test the system for leaks, airflow, and cooling performance, ensuring compliance with local codes. 12. How do you properly size an AC unit for a given space? To size an AC unit, calculate the space's cooling load using the manual J** method, considering square footage, insulation, windows, occupancy, and climate. Measure room dimensions and estimate BTUs, British thermal units, needed, typically 20 BTUs per square foot for residential spaces. Account for heat-generating appliances and sun exposure. Oversizing or undersizing reduces efficiency, so consult professional or use sizing software for accuracy. 13. What maintenance tasks should be performed regularly on an AC system? Regular AC maintenance includes cleaning or replacing air filters monthly, inspecting and cleaning evaporator and condenser coils, clearing drain lines to prevent clogs, and checking refrigerant levels. Lubricate moving parts like fan motors, tighten electrical connections, and inspect ductwork for leaks. Test thermostat accuracy, and clean the outdoor unit of debris. Schedule professional tune-ups annually to ensure optimal performance, efficiency, and longevity of the system. 14. How do you ensure proper airflow in an HVAC system? Ensure proper HVAC airflow by regularly replacing or cleaning air filters to prevent clogs. Inspect and clean evaporator and condenser coils to maintain heat exchange efficiency. Check ductwork for leaks or blockages, sealing gaps as needed. Verify that vents and registers are unblocked. Ensure the blower fan operates correctly and is clean. Schedule professional inspections to confirm adequate airflow, and address any system restrictions promptly. 15. What safety precautions do you take when working with electrical components in AC units? When working with AC electrical components, turn off power at the breaker to prevent shocks. Use insulated tools and wear rubber gloves and boots. Verify power is off with a multimeter. Follow lockout-tagout procedures. Avoid working in wet conditions to prevent short circuits. Ensure proper grounding of a unit. Adhere to local electrical codes and wear protective gear like safety glasses to minimize risks during repairs or maintenance. 16. How do you test a capacitor in an AC unit? To test an AC capacitor, turn off power to the unit and discharge the capacitor safely using a resistor. Use a multimeter set to capacitance mode to measure its rating against the label value. Alternatively, test for continuity to check for open or shorted circuits. If readings deviate significantly or show no capacitance, replace the capacitor. Always handle with care, as capacitors store electrical charge even when powered off. 17. What are the signs of faulty AC relay or contactor? Signs of faulty AC relay or contactor include the AC unit not turning on or off, intermittent operation, or unusual humming noises. Visual inspection may reveal burnt or pitted contacts, corrosion, or a stuck relay. The system may fail to cool or cycle properly. Test with multimeter for continuity or voltage issues. Replace the faulty component to restore proper function and prevent compressor damage. 18. How do you check and repair wiring issues in an HVAC system? To check HVAC wiring, turn off power and inspect wires for fraying, corrosion, or loose connections. Use a multimeter to test for continuity and proper voltage across circuits. Check for blown fuses or trip breakers. Tighten loose connections or replace damaged wires with matching gauge and insulation. Ensure compliance with electrical codes. Test the system after repairs to confirm functionality and address any underlying issues causing wiring damage. 19. How do you explain a complex AC problem to a customer in simple terms? To explain a complex AC issue, use simple language and analogies. For example, describe a refrigerant leak as a slow tire leak, reducing cooling power. Break down the problem into cause, effect, and solution, e.g., your AC isn't cooling because the refrigerant is low, like a car running low on gas. We'll find and fix the leak, then refill it. Encourage questions, avoid jargon, and confirm their understanding. 20. Describe a time you handled a difficult customer complaint about an AC repair. Once, a customer was upset about repeated AC failures post-repair. I listened calmly, acknowledging their frustration. I explained the issue, a hidden refrigerant leak missed initially. Using simple terms, comparing it to a slow puncture, I offered a free inspection, located the leak, and repaired it under warranty. Regular follow-ups ensured their satisfaction. This approach built trust, turning a frustrated customer into a loyal one, emphasizing clear communication and empathy. Mastering these top 20 AC interview questions and answers equips candidates with the technical knowledge and practical skills needed to excel as HVAC professionals. From understanding the refrigeration cycle and diagnosing complex issues like refrigerant leaks to performing proper installations and communicating effectively with customers, this comprehensive guide covers essential aspects of AC systems. By preparing thoroughly, candidates can confidently demonstrate their expertise in troubleshooting, maintenance, and electrical components, ensuring they stand out in interviews. With these insights, aspiring technicians are well prepared to tackle challenges and succeed in the dynamic field of air conditioning.